Welcome back. When we're studying equations in two variables, we're studying equations like we've done this chapter, this unit, with x's and y's. Now some people might ask, well, if we've got two variables, how do we solve if we've got two variables? Well, here's what happens. Two variables really looks like an ordered pair, which we've studied already. And so, for example, we might have an ordered pair that looks something like this. 2, 3. And that ordered pair is a set, it's a solution. A solution to an equation. The question is, what equation is it? And so when we test to see if something is a solution, all we have to do is plug in. And so what I'm going to do is I'm going to remember that this is x and y, and I'm going to plug it in to its appropriate place. And we're going to plug it in to test to see if it is a solution. Why? Because sometimes when we are dealing with problems that have multiple variables, say for example, the number of people that go to a party times the amount of dollars it costs per person, it can be confusing to find totals unless we have sample things to put in. And so this is what we're doing. So what we're going to do is we're going to substitute. So is 2 plus 3 equal to 5? Yes, that is a solution. It fits. So we would say 2 comma 3 is a solution. And that's all we're doing. We're testing to see if these solutions fit. And so in example 2, we're going to tell whether 7, negative 6 is a solution of x plus 3y equals 14. And so I'm going to remember that this is y and this is x. So is 7 plus 3 times negative 6 equal to 14? Well, I don't know, so let's solve it out. Negative 18 equal to 14. And what happens? This is going to be fairly easy. We're going to have minus 11 equals 14. Is that true? Well, obviously you're going to look at this and you're going to say, well, no, that's not true. So not a solution. Okay? So that's all you're going to do. So in B, you check to see if 4, 7 is a solution of 2x plus 3y equals 29. That's all there is to it. We're going to check to see if these solutions fit. How do we make this an easy process for ourselves? Well, sometimes when we get into the upper levels of math, we want to model this. And we're going to model this in pre-algebra. We're going to model these equations that have two variables, but we're going to put them in a certain form so that it's easier to look at and easier to deal with. That form is called function form. Function form is solved for y. For example, i.e., y equals negative 2x plus 15. Notice, y is by itself. So y is by itself. Here's not function form. Not function form. Not function form would be 2x plus y equals 15. Notice it's the same equation because I could subtract 2x from both sides and have 15 minus 2x, or minus 2x plus 15 equals y. Same equation, different forms, but it's not function form. And so what we're going to do first when we're finding solutions is we're going to solve for function form and then find some solutions. Let's see how it works. Write the equation 4x plus y equals 15 in function form, and that is solved for y. Then list 4 solutions. Well, where am I going to get those 4 solutions? Let's figure that out later. 4x plus y equals 15. And I want to solve for y. So I'll subtract 4x from both sides. This goes away. y equals 15 minus 4x, or more importantly, y equals negative 4x plus 15. There's a certain hierarchy of the way things go. We go with the x's, then the constants, or just the number part. This is function form. Function form. How do I find 4 solutions? Pick 4 x's. How do I pick 4 x's? I'm going to go with the first 4 that come to mind, and I would suggest you use these. Negative 1. X equals negative 1, 0, 1, 2. A little bit of negative, a little bit of positive, and 0 is always a good choice because a lot of times it cancels out. So let's see. Y equals negative 4x plus 15. So let's put in our 4 solutions. Y equals negative 4 times negative 1 plus 5. So this is going to be negative 4 times negative 1 is going to be 4 plus 5 equals y. Y equals 9. So my ordered pair is going to look like this. Negative 1, comma 9. Let's do our second one. Y equals negative 4 times 0 plus 5. So this is going to be 0 plus 5 equals y. Y equals 5. Second ordered pair is going to be 0, comma 5. Let's do another one. Y equals negative 4 times 1 plus 5. So that's going to be negative 4 plus 5 equals y. Y equals 1. You see how this is going? So my ordered pair is going to be 1, comma 1. My last solution, y equals negative 4 times 2 plus 5. So this is going to be negative 8 plus 5 equals y. Y equals negative 3. So my solution is going to be 2, comma, negative 3. Here are my 4 solutions. So this is the first part, this is the second part. Solve for function form, put in negative 1, 0, 1, 2. I want you to solve the second one by yourself. List 4 solutions. Use negative 1, 0, 1, 2 for domain, also known as x. So use negative 1, 0, 1, 2 for your domain, and then solve for those 4 solutions. Okay? Here's a puzzler. I want you to figure out, is x comma y comma z equal to 3, 1, 0 a solution of this equation? See what you get for that one. And if you don't have these notes printed out, print them out, or copy this example down. We're going to work on this one in class together. All right, guys? Thanks for watching, and we'll see you next time.